Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you get everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or building your CI pipeline, they just launched dedicated CPU instances. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference. Go to pythonpodcast.com/conferences to learn more and take advantage of our partner discounts when you register. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the newsletter, and read the show notes. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host as usual is Tobias Macey, and today I'm interviewing Martin Durant about Intake, a lightweight package for finding, investigating, loading, and disseminating data. So Martin, could you start by introducing yourself?
Hello, my name is Martin Durant. I work for Anaconda and have done for nearly 4 years now. I work in the open source part of the company, and I'm involved in packages such as Dask and file system things, file format loaders like FastParquet. But I've been on the team making Intake for a bit over a year, and Intake is now my main thing. So I'm the lead developer of Intake.
And do you remember how you first got introduced to Python?
I do. So it's been a while. In my former life, I used to be an astronomer. And when I started my postgrad studies, the people around me were using a thing called IDL to do the majority of their data analysis and plotting and that kind of thing. But my supervisor was using Fortran for much of that. So he told me, go off and use whatever you like. And after struggling with IDL for 6 months or a year or something like that, I heard of this thing called Python, which the Space Telescope Institute was getting interested in at the time. So I thought I'd give it a go. I sat down, I went all the way through the introductory tutorial on the Python site, and I never looked back. That was, I won't say how many years ago that was, but it was a few.
And so, as you said, now you have become the lead on the Intake project. So can you start by giving a bit of an overview about what the project is and the story behind why it was created?
Yep. Intake is been around as an idea, a sort of concept that something like this should exist for a while. And in fact, there are lots of packages out there that do some part of the work that Intake hopes to cover. But the specifics of the idea of Intake was, I believe, a year and a half ago, something like that, maybe a bit more. And it was an idea that was sort of very loosely born out of this loose Blaze concept that had been around at Continuum and then Anaconda for a long time. The sort of overall library that's going to bring together all of your data needs. The idea for Intake, though, was to be much more specific than any of that, to be at the cataloging and loading side, not to deal with many more complex things that you might want to do with data. Just give you a simple interface that is a layer over many other Python libraries, do the minimum necessary to let you get your data and then do all of your analysis and everything else in the way that suits you. So that was the initial concept. Python is, of course, very rich. There are lots of these libraries out there for loading from data format X, and Intake doesn't want to redo that work. It's very much in the vein of the PyData ecosystem, make use of what's out there and try and work well with all of them. So that's the idea. And it actually started in the, I think about January of last year, we started to actually have some working code at that time. And we released it in the summer as we announced it in blog posts, and I started to go to conferences, that kind of thing, to talk about it. And now it's thoroughly usable, and I encourage people to try it out. If you're listening to this, then I hope you find it interesting.
And as you mentioned, there are a number of other libraries, both in the Python ecosystem and elsewhere, that handle some of this data loading challenge. But as you said, intake is more for providing an abstraction and sort of unifying layer among them. But I'm wondering if you can talk a bit about some of the other projects that overlap some of the functionality of intake in terms of things like the data loading or the data cataloging. So I'm thinking of projects like Quilt Data or the Arrow project or Data Retriever.
The most common thing that people have said to me, aside from this is interesting and general comments, but the most common concrete thing that people have said to me when they've heard me talk about intake is, hey, my company has something like that. We tried to write a platform for doing just this thing, but we only got part way and it does some of it and then it got abandoned because the developer left or something like that. So it's very common. There are lots of proto intakes out there, ones that never even got released. And hopefully intake will be the thing that unifies all of these things. It's very much designed with simplicity in the code and use in mind. And some of them are actually available. So you mentioned I'll talk to Quilt and Data Retriever. The latter I actually hadn't heard about before coming to this conversation. I had to look it up. And it's very nice and simple. It gives you downloads of data files. There are a small limited number of formats that it supports. And it does that one thing. And I haven't actually tried it. Doubtless it does it quite well. Quilt, on the other hand, is quite different. It is a hosting environment. You give your data over to Quilt, they manage it, and then you get an API to their system, which allows you to see what data you have and access whichever of those data sets that you want to have. Intake, I started off by saying it wants to be simple. It wants to do the minimum amount of work. It doesn't host your data. Your data can live wherever you want it to live. So that could be on shared disk drives. It could be on GitHub. It could be on Amazon S3. It could be in a number of places, including your local disk. But that's just one of many. And the catalogs themselves can live in all of these different places. So if you want to use intake to share data, you can just put your catalog into, for example, a gist on GitHub or a repo, point people at that, and you don't need infrastructure, you don't need a server, you don't need to set up anything, you can just load it and go. So it really is going for that simplicity of use. In the data retriever case, that is also functionality that is covered by intake. Intake has a caching system, optional, and it's the catalog author that gets to decide whether a particular data set ought to be cached or not. And caching can mean downloading the files that hold the data, or it can mean accessing some data resource, whether it's a database or whatever it may be, and forming that into a local version. So for example, for tabular data, it would be Parquet files. And that's an interesting thing that we've started with from the very first step with intake, is that we want to be able to support not just data frames, not just arrays. We want to really give a uniform experience across all the different kinds of data that are out there, all the different places that data may live, whether it's services, whether it's remote storage, but still give a very simple experience to the end user. Arrow, I think we can talk about separately. It's not the space that Arrow is in. Arrow is in data memory format. It does care about loading data to some extent for a couple of formats. Maybe down the line that will grow. And it does have some hooks for remote file systems, particularly HDFS, maybe some more coming. But for the time being, it's really about representation of data in memory and passing data between processes. So it's sidelong to what intake does. It's not really the same territory, I don't think.
And so intake is built to be able to simplify a lot of the workflow for data scientists and data engineers and reduce issues of code duplication that are required for being able to obtain and prepare the data for analysis. I'm curious if you can talk through just the overall workflow of using intake from the perspective of both a data scientist who is consuming it for building these analyses and a data engineer who is likely defining and maintaining the catalogs and the data sources.
That idea of separation of concerns between the owner of the data and the user of the data is really core to how we designed intake. We want the user, and the user is, they will be more numerous, so often they're the ones that shout the loudest, but we want their experience to be simple. We want them to be able to find some abstract cataloging thing where they don't need to worry about how those catalogs are created and how they reference one another. To be able to search through those, know the metadata of the data sets themselves, and use a single method to get a handle to the data, whether it's in memory or some Dask thing or some Spark thing or whatever it is that they're used to analyzing it with. It should be a one-liner once they found a data set of interest to be able to work with it. And then intake is done, and they can get on with the actual work that they're paid to do. So from their point of view, they shouldn't really notice intake that much. They may be using our GUI, they may be using search functionality, that kind of thing, but the less interaction that they have with intake that nevertheless lets them get on with their job, the better it is from the end user's point of view. From the engineer's point of view, or the data owners, they create the catalogs or cataloging systems. Often there will be the same people that curate the data, so they decide this particular data set is the authoritative version of whatever it is that it's supposed to be. And at that time that they are doing that curation is when you want to capture as much metadata about it as you can. And that process is very important. And intake provides a very simple way in the base case, at least, a very simple way of writing down all of that metadata. You can just include it into a YAML file as a dictionary-like thing and put everything into that metadata block that you, as the catalog author, find interesting. But you also provide the set of arguments to the particular loader. We call these data drivers. The particular set of arguments which will load that data in the way that it ought to be loaded. So you might have a choice of different packages to load it with. You might have a choice of various specific options that make sense for that data type. Maybe only some columns of a particular data set are of interest if you think about this data in one particular context, you can have multiple versions of it. Maybe you could present some specific options to the end user. Do you want the production set? Do you want the latest leading edge set or something like that, or just a sandbox version? All of those things you could encode into a catalog. You can also structure these catalogs so that they reference one another in a hierarchical model. And that's, again, a clue to the user on how to go about finding the correct data that they need. So the idea, the best situation from the data engineer's point of view is that the data users know what data is out there. So it's a way of doing this dissemination piece just by, in the simplest case, putting YAML files in the correct position. It can be more complicated than that too if you need something more specific. And then the user, because they've used intake before, they know that the same three methods of interest will do everything that they need. They shouldn't need to come back constantly to the data engineer saying, hey, I need this latest bit. Hey, how do I load this thing? Or to go to their colleagues saying, do you have that little piece of code that loads the current data set that I need to work on? So by making clear the different roles around this data story, you save everybody a lot of work.
And as far as the metadata that you can embed in the catalog definition, I'm assuming that that's also passed on to the end user for being able to inquire about some of the different attributes of the data, such as what you were saying as far as the different columns that are of interest, or maybe having a last generated timestamp so that somebody can inquire about the freshness of the data that they're analyzing without having to go back to the catalog owner to ask that question.
Yes, although all of it is optional. You could have an empty metadata section if you chose to make a catalog that way. That's obviously not recommended. This is the value added, is being able to include information in this. Some specific things that come from the data set itself. So the number of the columns that are available is usually something, depending on the data format, that the data itself can tell you. So that's already often encoded in some kind of metadata. For Parquet, for example, there's a special part of the file that has a list of the columns that you expect to get there. Other things, like if it's, say, JSON, you might not know what columns exist. There's no specific metadata location in the common JSON. Maybe you have a JSON API description or something. So there are lots of possibilities. And the design of how you get this encoded into metadata is one of the most important considerations when you write a data driver. There will be some common things. People will want to know timestamps. They will want to know tags, for example, is a common use case. So category of data, for example, if you want to find all of the data sets that are in the sales category, then you should be able to search sales and it will find all of them because it's there in the metadata. And that's already possible now. Timestamp is actually a bit more subtle because commonly it's latest is the timestamp, because you're loading from some remote location and the data in that location can be updated in place, which is very useful. But then then the question of versioning is another interesting topic that maybe we can talk about later, especially if your data source is actually some database system, and not only do you, instead of having a new version of files, you have new entries in there, you have individual updates to individual rows, and you're not normally in the database case talking about versions of data. Usually you are getting the latest. Maybe you have some snapshotting capability.
And going back to the catalog definition again, you mentioned the ability to have them defined hierarchically. And I know that in terms of data, particularly as you start to accrue a larger volume and variety of it, it can be difficult to understand just what data is even available, what exists, and what the overall discovery and cataloging capabilities are. And so I'm wondering how Intake addresses some of those problems. And at a high level, it seems that you could have one catalog definition that's just a sort of meta definition that defines all of the other catalogs that exist that just gets updated as you add new data sources. But I'm wondering if you can just talk through the overall experience of the discovery process for working with Intake and understanding what data exists within an organization.
In the Intake model, a catalog object is itself a data source. So any catalog can refer to any other catalog as one of its entries. And that can be most commonly just a URL, or it can be something more complicated. But you can imagine a simple case in which, let's say you have your data on S3, you could have your catalog definitions also on S3 as a particular bucket and key is your master catalog, and in it, as you say, this could just be a YAML file, and each of your YAML blocks within there, each of your entries, it says this is a catalog and it's at this other URL. From the user's point of view, they would load the first one of these, or maybe their system administrator has provided it as one of the automatic lookups that Intake does for you at import time, and then it's just there. And you can do a list of your master catalog, and you will see it has a certain number of entries, and that those entries are themselves catalogs. You can do a search method, which will walk down into the hierarchy looking for particular terms in the metadata and description of all of those data sets. Or something that has now been heavily developed and is becoming a pretty pleasant experience. We have a GUI, which you can launch either in a notebook or as a standalone application, with which you can click down the tree of your catalogs and see what entries are in there. And for each of those entries, you can see their description and metadata in front of you. You don't need to type anything to do that. And also coming soon, this is also already partly implemented. You can do some on-the-fly analysis and visualization of those data sets within the interface itself. That obviously will work better for certain sizes of data sets than others, and we need to care then about where is the execution happening. If you're doing some aggregated visualization, or you actually just want to see the data, you still have to load it in some process somewhere to display it. So it does open a new set of questions, but in general, this idea that whatever execution environment you are using anyway is the thing that's going to get you some quick look on your data, perhaps with some great subsampling, maybe only display 1 in 1,000 rows or something like that. That is all possible within the interface, or it will be very soon. So then the user of the data can know pretty rapidly if that's actually the correct data set that they want for the job in hand. There are some additional niceties about this. Catalogs are hierarchical, but they're not exclusive. It's not like a directory, a disk directory hierarchy. So there's not only one parent per catalog. You can cross-reference them. You can have multiple entries to the same set of files or the same data service, but with different options, where you can then describe what those different options are. And again, following those descriptions and metadata, the user can pick the one that's correct for them. I already mentioned parameters that you expose to the user so that they can make some choices at load time if they need to. Those parameters can include credentials, which is a fairly important story within commercial institution, to have the correct identity attached to each data access. That's something that intake doesn't store those credentials, but it provides ways to pass those credentials on. And I've wandered a little far from hierarchies now, but yeah, the basic idea is that you can click through your hierarchy, you can search through your hierarchy, or you can do all of these things in code if you want to. So we expose as many different ways to do these things as possible.
And so another challenge that comes up often when dealing with data is the idea of capturing the lineage or provenance, and that can change as some of the sources change or the manipulations of what generates a derived data source changes, and that ties into the versioning aspect that you mentioned as well. So I'm wondering if you can just talk through a bit about the data lineage capabilities of intake and also some of the story around data versioning and catalog versioning.
For the time being, intake is something that reads your data and doesn't write it. So you wouldn't use intake to derive a new data set from a previous one. You would use intake to load it and then manipulate it however you want to. We are developing hooks to be able to edit catalogs in place so that you can add new entries into them. And that would be the opportunity to add extra information about the current session of how it was generated. That kind of thing often makes sense in the context of a larger processing framework. So you may be aware that Anaconda has a 4-fee enterprise platform within which, whenever you're in the platform, you're running within some container, and that container knows a various amounts of information about who the user is and what the resources are, what the environment is, that kind of thing. So if you were saving data into an intake catalog from such a system, then you would have a lot of information about how it was generated, especially if it's a job that is something that's run regularly in an express declarative way, as opposed to at an interactive prompt. Python being Python, you can do anything at an interactive prompt, right? So the more constrained your execution environment, the more information you can have, and then it's up to the administrator of the data system to capture that information at the time that data is ingested. Intake may eventually go down this road of being more of a data pipeline type system in which it actually does analyses for you and executes jobs that does that kind of thing. For the time being, we're of the opinion that we want to do the one thing, which is loading extremely well, and to go to both sides of that story, the reading and writing, and become some kind of Dremio-like system or whatever. There's a whole load of those kind of systems around too, would actually make intake less good at the particular thing that it's aimed at. So we're very hesitant to try and do too much with intake, certainly in the near to medium future. The only exception to this rule is that there is a functionality in intake called persist, which is read the data from remote, typically a database or something where your query would take a long time to process, and then write that table or array or whatever it may be to a local format as is. And then, because we've made the data ourselves, we can capture all these things about where it came from, the time that it was executed, and be able to refer back to the original data, so that at a later stage, you can either automatically say this data is now stale, we need to refresh it, or the user can say, I would like the most recent version of this data. So that's one side of it. When it comes to working with the versions of the data itself, though, for reading, that is something that is currently under development, and it will depend on how you want to store your data. There are many different places that your data can live, and each of those may have a different concept of what data versioning means. Probably the first one of these that will expose directly to the user will be Git, because Git is the best known versioning thing that's out there. And Git makes a very natural storage place for your catalogs. Catalogs can be text files, as I've said a few times. YAML is the standard format that we use. So you can be versioning your catalogs using Git anyway. But if you have a reference to a repo, and you regard that repo as a cacheable thing, then Intake can take care of cloning that repo, offering the set of versions, maybe just tags, this is something to be decided, and exposing those to the user so that they can get latest, or they can go back in time. There are a number of things like that I would regard as caching mechanisms. That is, you can get a local copy of some data that lives elsewhere. Docker is another obvious one that uses versions of that sort. One we already have implemented, which is implemented but experimental, is DAT. DAT is a much bigger data concern, but one in which you have absolute hashes to every version of your data so that you can very much reproduce the data at a particular point in time. So Intake can interact with that. You can say my data lives in this DAT hash, and at the time of access, Intake will call that and have that do that referencing for you. So again, it's not Intake that's keeping hold of the versions. It's an external provider of versioning information. Intake maybe will have the ability to do snapshots itself of, in the same way that currently we can persist data from remote and we can cache data from remote, maybe we will eventually version those things so you can have snapshots of them locally. Exactly how that will be done and what the experience will be, that's something to be decided. But it's probably something that will appear in the next 6 months, I would reckon.
And so, can you describe a bit now about how Intake itself is actually implemented and some of the extension points that it provides for somebody who wants to customize for different data sources or different container formats that it'll support?
Yeah, we've tried to make Intake approachable to the developer. We have a simple class structure so that if you want to implement something like a data driver, or indeed a catalog, which is a specific type of data driver, then you need to just derive from a particular class and implement a small number of methods, I think like 5 or 6 methods on there. And these classes, in a simple case for something fairly straightforward like text file maybe, end up being pretty short. They're basically one page of code. I have a tutorial lying around that was using the GitHub API as a data source. So the parameters that you would pass to it would be the repo that you're interested in, and the type. It was the issues for this. It was just a throwaway example. So the type of issues, whether it's open or closed, those are the parameters that it took. It connected to GitHub, and it would give you back all of those issues with timestamps and author and whatever else as a data frame in that case. And the code to do that and make it look like any other Intake data source is maybe 50 lines or something like that, probably less. 50 lines including class declaration and documentation and that kind of thing. There are some other extension points in there. So you mentioned container formats. The containers are, again, a specialized data source. We haven't mentioned the Intake server at all. It is something that might be very useful to people, but it does really complicate the set of things that Intake can do. For this conversation, I'll just say that there is an Intake server, which you can just run as a Python process. You don't need to have any special infrastructure for it. And it can serve catalogs. So you can connect to this server and it gives back a list of data entries or sets of catalogs. And The second use for the server is that you can actually stream data from it. So it may be that the server it lives behind a firewall, or it has some special credentials access so that it can see data that the user on a different machine can't. And then you can use the server to stream that data over a single socket. So that's a very nice convenience. But to be able to do that, you need to agree on what that data type is. So for basic things like arrays and data frames, those are plumbed into intake. So if you expose a data frame from the server and the client wants to be able to load this proxying through the server, then it gets chunks off that data frame, and it doesn't need to know what the original format was. Perhaps it doesn't have that driver, and that's the reason that you want to proxy, is because the server has the driver, but the client doesn't. Those few types, like data frame and array, we call those containers, and it's also the thing that's responsible for if you do a persist, then for data frame, it gets written as a Parquet set of Parquet files, and where that definition is that because it's a data frame, that container, the definition of the data frame container, has a persist method, and that defines how it gets written to disk locally, and it turns into Parquet for all cases. Writing a new container is similarly pretty easy. So we have a couple. We have GeoPandas, so a specialized data frame in which you have a notion of geometry, and Xarray, which are related sets of numerical arrays where you have coordinates and metadata and perhaps some hierarchical structure to them in the sort of NetCDF-like model of data format. So those were new, and they live outside of the main intake repo, but you can use them easily in conjunction with intake. If you had some other type of data, and we're looking, for example, at streaming data, at fitted machine learning models, these are interesting things that you might want to be able to pass from one place to another without having to do the basic load yourself. Those are all candidates that would be fairly simple to implement. It's just a matter of time of somebody getting around to doing it. In practice, data frames and arrays and free-form text-like things such as JSON, they fill the needs of the great majority of users, certainly in their business case. But the fact that there are lots of different types of data out there is something that is often glossed over in other data access conversations out there. I don't just want 20 different ways to load data frames. Loading from XML is not very different from loading from JSON. So in my mind, those two are the same thing, really. But there are lots of fundamentally different types of data in existence that often you just don't have a convenient way of loading at all.
And as far as the overall implementation of intake, you mentioned that it's a fairly young project. So I'm curious what some of the assumptions are that are sort of baked into the origins of intake and how it's designed, and some of the ways that the architecture has evolved, and maybe some of the ways that those assumptions have been challenged or updated in the process.
It's a tricky thing to ask a software author what their assumptions are. It's easier to see from the outside, of course. We did start off with a concrete set of data sources that we were interested in, which was partly driven by an external client of the company. So they had their own interests. So we implemented those first. And some of them just don't get used. For example, we have or at least don't get used as far as I know. There may be people out there that do and they're happy with them, but you could say perhaps there's absolutely no problems with them, and that's why I haven't heard from them, but I suspect that they don't get used very much. So Solar, for example, is a queryable database-ish service typically used for system logging on some cluster. So there are doubtless lots of Solar systems out there, that's SOLR, but probably not that many people using intake to derive data frames from Solr queries, because you would typically use it with a graphical front end where you want to do anomaly detection or something like that. So there are a few of those that we initially made and then realized that these are probably not the most important ones to be working on. I think what I said just before of the untouched data types that are out there that are there's a huge number of them and there's a huge amount of data in them, and if we just follow on trying to make data frame like things, then we'll be missing out on those, and the people that want to be able to load from those things will also be missing out. So I think that that's the biggest pivot, is to realize, and we had talked about this early on, but to really extend the sets of data types that intake can interact with. So at the moment, I've started a Scratch repo on streaming data. There are not many frameworks in the Python ecosystem that deal with really real-time data. So there is one that I'm now developing called Streams with a Z at the end. And it seems like a fairly good candidate for being able to do this. Since I now develop for it, I can customize it to be friendly to intake. Of course, that's convenient, but exactly how the user experience of that will be is not yet entirely clear. And that is the kind of thing that makes me wonder whether there are some things in intake that, you know, we're a bit too set in our ways, concrete files, concrete versions of data. But now we have something that's truly dynamic. What do we need to change to make that work?
And as you mentioned early on, intake focuses primarily on integrating with the PyData ecosystem and solving a lot of the problems that developers in that space are encountering. And I'm wondering, what are some of the other types of communities that either are currently or could be benefiting from the work being done on intake?
I think I'd start off by saying that the PyData ecosystem is truly enormous. If it encompasses people, basically anybody who's using NumPy or Pandas or scikit-learn or even related things like TensorFlow, those are all PyData ecosystem players. Some are more deeply integrated with other tools than others, but that's the nature of things. Python makes it very easy to play along with all of the different libraries that are out there. It's about finding the users rather than the code ecosystems, I think. I think if all of the people that currently use Python for data analysis, if a significant fraction of those would be using intake to catalog those data systems and to access their data, then that would be an enormous number of people. And I'd say let us get to that point before we try and say who else might be benefiting from it. We're not particularly at the stage. I think you were going to ask me this later, of cross-platform interoperability is something that we think about and we try and make it possible in some cases, but intake itself remains implemented in Python, and it will be for the time being. So all that we can promise is that where there is a platform-independent description of a data set, and there are quite a few of these different ways of doing it, that intake is capable of interoperating with them, and ideally of expressing its own catalogs in those formats as well. So both of those, particularly the first option of being able to read their data, that is something that there are already several examples of, such as Stack and Threads are scientific data description standards, and intake can read from those catalogs and expose their data as X-ray objects. But being able to go the other way, taking intake catalogs and generating those platform-independent prescriptions is also something that is being worked on already. And if that's there, then you don't anymore need to ask the question of, hey, shouldn't intake also be implemented in R, for example? Maybe it should. Maybe somewhere a couple of years from now that can be something that we think about, but definitely not for the time being.
Yeah, it's definitely valuable to have an understanding of the scope that you're aiming for and the limitations that you're willing to accept in order to serve your target community well, rather than trying to be everything to everyone and ultimately being useless to everyone.
Yeah, and obviously that we have a bit of bias at Anaconda. We support and we develop for R2, but Anaconda is unofficially, perhaps, Python first, and we have a much bigger name in the Python world, and we develop a lot of Python-oriented open source products and projects, I should say, I guess, if it's open source. So the convenience that I know people that develop PyVis. So if I need some visualization stuff tailored to the intake need, then that's a very easy conversation for me to have. That doesn't mean that I want to convert the whole world away from, I don't know, Plotly or Matplotlib or whatever. It's just that we can move a lot faster within that.
And in terms of the overall work of building and maintaining the intake project, what have you found to be some of the most challenging or complex or sort of unexpected aspects of building and maintaining it?
Personally, the biggest problem, the hardest thing really has been the messaging from the start. This is a tool that people don't necessarily realize would be useful for them until they've seen it demonstrated, until they've seen some real concrete examples, until lots of other people have created intake catalogs of their data as an easy way to share it. I can make talks, I can talk about intake, and people generally find those quite interesting, and it's a novel idea for them. But actually getting people on board and using it requires crossing a certain hurdle, a certain amount of effort for some institution or individual data handling person to make that effort to actually come over and use intake. It's very much a different experience to when I was writing FastParquet or when I was writing S3FS for accessing S3. Those were needs that people already had, and they were waiting for a library that fulfilled that function for them. And then it came and people used it and they were very grateful. In this case, it is this finding out exactly what people's pain point is so that I can address, hey, is this something that you're struggling with? Are you aware that intake can do this for you? Intake has perhaps already too many facets, too many functionality pieces within it, so that the very front page of the intake documentation has like the 4 main use cases. Are you one of these people? 4 is already quite a lot. It's much easier when you say, this is what you're trying to do, this is the thing that solves it for you. Quite getting that tone right is definitely far and away the thing that I have found the hardest. So I appreciate conversations like this to try and make it as clear as possible what it is that we're after, why we're working on intake.
And as far as your experience of using intake on your own and helping some of your customers and community members leverage intake, what have you found to be some of the most interesting or unexpected or innovative ways that you've seen it leveraged?
So I know a fair number of scientists, particularly in the atmospheric community and the Pangeo collaboration, that have taken on intake wholesale, and they have some pretty massive catalogs now that they routinely use in their deployment. And a lot of data is referenced in those catalogs, and they use it every day in a very open way, so anybody can access these catalogs and know what those data sets are. There is one particular project to take that set of intake catalogs, and it is itself a GitHub repo, so you can submit to this GitHub repo. They have CI on it, which takes all of these prescriptions and checks that you can actually load all of those data sets, and then it takes them and it renders it all into a very handy website so that you can, that's another way, that like an unofficial way, if you like, to browse through intake catalogs, is that there is this one particular project within which they render everything into static HTML so that you can just click through the whole thing. So that's pretty cool. And then a different collaborator, this is at Brookhaven, I believe, so scientists again, but of a different type, in which they've taken an existing experimental data repo. So that's implemented in MongoDB, and that keeps track of every single experiment that is done within this particular group. A very, absolutely, truly massive amount of information that is in there. And they've implemented an intake hook to this so that you access the server. It looks like a catalog from the user's point of view, They submit some basic query parameters, and the server, when it gives you the catalog back, what it's actually done, it's taken this query and it's talked to Mongo, and from Mongo, it's got back a list of entities. These are all data sets, and then it's packaged that into something that to the user looks like an intake catalog so that they can just load the individual data sets from a source. That's the kind of next order intake thing. We're no longer talking about just files. Writing things into YAML files is really quick way, very convenient to get going, but actually you can do this on a much bigger scale without having to write a lot of code at all, without having to institute complicated cluster topologies or anything like that. So there's a couple of examples that have impressed me. I try and maintain there's an examples page on the intake docs. So I try and maintain links to all of these different things. People who are building, like I mentioned, stack and threads, and CMIP is another one of these scientific standards, people who maintain those. And you can see all the different data sets that get added to these collections. And I'm not a scientist in their field. I have no idea what these things are. I just know that they look really complicated and there's a massive amount of stuff there. So yeah, I find those things very impressive, and it's really quite gratifying to see other people who are working within this intake landscape.
And are there any other aspects of the intake project or the challenges of loading and processing data that we didn't discuss yet that you'd like to cover before we close out the show?
It's a pretty open space. So intake is young. We're very much open to having people propose things that we haven't thought of. We have, at Anaconda, we have certain customers. Someone like me, I have particular experience with what I've done with data and open source projects that I've worked on, but this is really just the edge or tip of the iceberg, if you like. So there are so many things out there. Come and talk to us. Hey, this is a kind of data, or this is a data curation system that we're interested in. How would I go about writing an implementation for intake to be able to interface with this thing? And that includes, for example, we started off with data retriever, this tidy little library that loads some stuff for you in a very particular way. Intake could be a layer over that too. Hey, here is one of your catalogs that is referenced from your master catalog, just happens to be all of your data sets that live in data retriever. You have another entry that sits next to it. These are all of your tables that live on your Spark cluster, for example. You can totally do that. So intake wants to be really this very light and simple layer over everything else that might exist. And what we need are users and use cases above all. For the actual aspect of getting things into memory or loading things in chunks into a cluster, the kind of thing that Dask does, those are that detail I find interesting, and there are so many different ways of doing it, and so many different ways of storing your data. Usually a lot of that code already exists somewhere. So usually it's a case of writing something that can call that code in a structured way that makes sense from the intake point of view. It's usually quite easy.
And for anybody who does want to follow along with the work that you're doing or provide feedback or suggestions for intake or follow it along as it continues to grow and mature, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose a tool called Ubersuggest that is just a handy little website for doing some easy sort of SEO analysis for things like keywords and backlinks for your website, which is something that I've been trying to work on for the podcast. So I found that to be useful. And so with that, I'll pass it to you, Martin. Do you have any picks this week?
I haven't actually had time to pick anything.
Well, I want to thank you for taking the time today to join me and discuss the work that you're doing on intake. It's definitely an interesting tool, and it's great to see another entry into trying to make it easy for people to have a opinionated and standardized method for accessing and analyzing their data. So I look forward to experimenting with that on my own, and I hope you enjoy the rest of your day.
I wonder, before you go, how did you come across data retriever? As I say, I'd never heard of it. So you wanted to write about intake and you did some Google search, I suppose, or did you already know about it?
Data retriever I actually had on a previous episode, so I'll add a link to that in the show notes. And I think I just saw it in one of the Python newsletters that went went out. I think it was maybe a couple of years ago at this point.
Okay. All right. Thank you.
Thank you for your time.